I'm your host, Keith Ingersoll. So just a little bit about me. I'm a senior data scientist at Civis. Civis Analytics is a software and services company based in Chicago. We sell consulting services as well as a data science platform, which is software useful for like consolidating all of your data science workflows in one place, from like databases and like compute instances to like how do you deploy some of these web apps that I will be talking about today. It's kind of an interesting company, and I get a good mix of like deploying apps and also like talking to consultants in the companies that make these. So that will inform a lot of what I'm talking about today. Personally, I work a lot on text analytics, NLP, and working on sort of the API clients to the software that we sell. I think typical for a lot of data scientists, I do a lot of my machine learning, like TensorFlow, like count vectorizers, TF-IF vectorizers, like all of that. I really love Python for, but I'm a lot more familiar with Viz and R. It's kind of just what I have been falling back on, and that's sort of one of the inspirations for the talk. My team and I were thinking like, what is out there in Python to do data viz, so we don't have to use two languages to do one thing. That would be great. Okay, so why are data science web apps great? And I think they're great because they enable both like technical and non-technical users to be more effective in how they use data. So, for example, like charts and maps, when we see them, we have like sort of, natural heuristics where, like if you see a bar chart, you can see the relative importance of two like sizes. Whereas if you have two numbers, it's just harder to do. And web apps are like a good way to show charts. There's interactivity in web apps, and this is kind of great because like before, if you just send somebody like one thing, like one chart, they might be like, oh, that's great, but like what if I were to like look at that among, just this kind of like person or like this filter? And you'd have to send like that person a question, and then they would like misunderstand the question, and it would take a long time going back and forth. Whereas now you can just build an app, and you can just like click a filter and just look at what you want. And they also encourage reproducible results. So if you are putting data in a slide and you like make changes to the slides, you maybe can't exactly do that again. And then someone will ask you like in 2 weeks, like, why is this happening? And you don't know because you can't reproduce it. Awesome. So I want to be concrete about what I mean by data science web app. I don't think that's really a common term. And I'm using it as sort of encompass like the Jupyter notebooks, R Shiny dashboards, like the whole landscape. I'm kind of excluding like custom built like React or D3 apps. It's kind of arbitrary, but I think that it's that's what I mean is like these apps that are written in R or Python, and that gets translated to JavaScript. I think they're usually kind of small, just like a dashboard or a couple of tabs. If they get bigger, maybe it does make sense to do something in a proper JavaScript framework. And they usually include like charts or maps. Okay, so why no JavaScript? This is sort of like, I don't think this is like great evidence, but some evidence from the Stack Overflow survey that like among developers, like data scientists, machine learning specialists, they want to learn Python, they want to use Python. They're at like the top of the developers who want to use Python, whereas they're at the bottom of devs who want to use JavaScript. So like you can kind of say like these people want to work in Python and they don't want to work in JavaScript. JavaScript is also just another thing to learn, so I think I understand like just it's faster to use the language you already know. Okay. So here is an example of an app. This is a very useful app. It lets you change the color of the scatter plot. The reason I'm showing this is because this is built by Marshall, as he put on the top, by Marshall. He's our director of product. So he's used R in the past, but he's doesn't code in his job. He's in product. But he thought like these apps are so cool. This is so fun. Like, can I build one? And he did in like 20 minutes. So I think they're pretty easy to use. They're fun, And I think they're especially nice as an alternative to like the default, which is PowerPoint. This is my presentation is made in Google Slides. It's made in Slides, and it's great for presentations. But there's like a lot of limitations when you're delivering like data analysis. I don't think it's like a great medium because it's hard to programmatically update. You'll send someone the slides, and you'll say like, here's the latest version. Use this one, and then they'll use the other one, and it will be wrong. Then there's formatting. It's hard to put text next to plots, and I think it can be a headache. And Tableau is a little better. Tableau is pretty quick to build dashboards. The consultants I talk to at my company do like to use Tableau for some things, but it also has limitations, and it doesn't natively like interact as well with the code that everyone's writing. Okay, so now I'm going to go through like a flow chart of sort of building these apps, kind of based on the apps that I built, but also talking to other people. So the first question is always, did the stakeholder ask for a PowerPoint presentation? And the answer is yes, often. So then you think, can I change their mind? It is a joke, but it's also not a joke because I feel like this is sort of what you have to do. This is the position everyone's in. It's like, how can you convince someone to change their mind that they don't want PowerPoint? So maybe I will have given some examples about why PowerPoint is not as good because it's not interactive and it's not programmatic. Okay, but let's say that you can't. So then you might say, like, how about a PDF instead? PDFs might be a little easier to create. So based on this answer, you would, you could create a PDF with like R Markdown or a notebook and use MB Convert, or you could create a PowerPoint and use there are some packages out there to do this. They're not terribly easy to use and they don't always look great. It requires some work. Okay, but let's say we live in an ideal world and we were able to convince the stakeholder that they do want a data science web app. So then I'll do a quick aside. So the first kind of thought or the first kind of decision we need to make when we make a web app is like, what kind do we make? Do we want to make just a front end only, which is just like HTML with JavaScript in it? Or do we want a server as well? There's a lot of advantages to just doing a front end only app because you can deploy it on like S3 on, it's just kind of simple to maintain. It doesn't have a server that could go down and then someone calls you and you're on vacation. And there's a lot of tools out there that will translate your Python code directly to JavaScript so everything can run in the browser. For example, HTML widgets like R and Crosstalk is R. IPy widgets, also known as Jupyter widgets. There's also IPy widgets JS link, which is really cool, and that like will translate reactive, kind of like interactive widgets, so you can do filtering of your charts, and that's all in JavaScript, so it all can fit in the front end. Front end server, this allows you to like access a database and basically do anything you want and run custom R and Python code. Okay, so given those kind of constraints, the first question we'll ask is like, can our data fit in the browser? So if we have, let's say we just have an aggregation of some data, so we have like a few thousand rows and it's easy to fit, so yes. Okay, the next question that we would ask is, do we have specialized code that we want to execute at runtime? So we can translate some Python code to JavaScript, but if we have like a scikit-learn model that we want to run, we can't really translate that to JavaScript. Interestingly, there are some packages out there to run and even train TensorFlow models in the browser, which is kind of a brave new world. Okay, so no. So we don't have any special code. We're just showing a dashboard. Then we can use some of these tools to do that. And this is just like a front-end only HTML would be our deliverable. Okay, so if our data can't fit in the browser, if we need to access a database, then we need to take a different route. Or if we have some like optimization code, something special that we can't translate to JavaScript, we also need to ask this question. So next one, can you ask viewers to run your code? So if this is code that you're just sharing with your colleagues, sharing with people at your company, or if it's public, then you can just share a notebook. That's really great. It shows all the code, how you did it, and then all the charts. There's R notebooks, there's Jupyter notebooks. Kind of does assume that the user is technical. I don't think that you would necessarily like pass a notebook along to like your CEO unless your CEO is like a computer programmer. So if the data is like we can't share the data, we can't share the code, or the user is not technical, then we need to build sort of like a front end server app. Shiny is like definitively what you would use in R. In Python, I don't really know what the standard is. It could be bouquet, it could be dash. There's not a standard there. So to recap, there's like kind of 4 deliverables. I think there's like read-only reports, PDFs, slides. You have to send somebody something new when you want to like make a change. Then there's the web apps, which is like front end only, single HTML page. There's some limitations on data size and what can be converted to JavaScript. Shared code. This is what I mean by notebooks. I don't know if that's the best word, but that's kind of the conception. Like you just pass over everything and they can just rerun it. There are ways with Binder to like embed notebooks in the web so that someone doesn't have to have the same environment as you. That can be a big problem. For instance, it might be really tricky to install TensorFlow. And then fully flexible apps, these are like anything goes. But then you have to, with everything, with great power comes great responsibility. Okay. So now I'm just going to run over a little bit of code just comparing 2 apps. I'm going to compare Bouquet and Shiny just to see like the flavor of how they look. Yeah, so here is the app that I used to make these charts that I showed earlier. So what I do is I have this app and then you can just save. Like this is actually Bouquet calling from R. So the Bouquet library has like backend code and also has like JavaScript code, and there's an R wrapper for the JavaScript code. So in a way, this is sort of like sneaking in a little bit of Python into your R world, which is always a good thing. Okay, cool. So the code to make this looks like this, at least the pseudocode. I am hiding some code. The paradigm of Shiny is really, let's see if I can you, yeah. You have like the UI, and then you have the server. There's like a very clear distinction about you have like what is the front end code that you're going to write, what is the back end code that you're going to write. And look at how, I mean, this is so short. This is like, I don't know how many lines of code this is, but this is really small. So for the UI, we will define like a sidebar layout. So you have the filters on the left, and you have the main panel, our bouquet output on the right. The way that we pass information along is through a global input variable. So right here, this is going to pass like the language input into a variable called input language, and this is going to pass like work or want, like whether you want to work with this language or whether you want to, or whether you have worked with it. That widget is here, and that gets some relationship. So then in the server, this code is like looped over and over and over again. And what it does is it looks for like what is the state of the widgets, what is the input language, what is the input relationship. This is like creating a new title for the chart. Then we filter our data based on that, and then we plot the figure. And what's kind of powerful with this is like we can plot any kind of figure here. We could plot a ggplot. We could plot our bouquet, plotly. There's like many different things. We would have to change this up here, but it's pretty similar. So then the connection here, this code will look for like what is the current widget state. If any of like the filters have changed, it will change the plot. Then it passes the change to the output, which is the bar chart. And then right here, this is saying here's the bar chart. It's saying okay, plot this. So then you'll see in the UI the change immediately. Great, and then you just call it with Shiny App, UI down here. Awesome. So this is the similar app made with Bouquet. So I'm less familiar with Bouquet, and it took me, I'd say, quite a lot longer to build this app. I haven't done some things. Looks very similar. There's no x-axis, so xkcd would be angry at me, and rightfully so, because what is the x-axis? Okay, and this is the code to generate this. So there's a lot more code that I'm hiding up here where I set up some global variables. Like here's the data frame, the pandas data frame. Widget state is a global dictionary that I created, and that just says like, okay, what are the filters at right now? And then I actually created the bouquet bar bar chart up here as well. So that's like the first thing that happens. So the paradigm here is not, there's really not like the clear UI server like definitive opinion. I think that this is probably like more like the standard way of thinking about these apps with callbacks. So it's definitely more like, what is like the standard for how you do these, but less like maybe easy and intuitive for someone who hasn't done it before. So what we do here is we create the widgets, and then we create the bar chart, and that gets put in the layout down here. So that's where the layout is. And then we add callbacks to the filters here. So like the radio buttons, the select, they each have a handler. And in the handlers, what we do is we update the global state. Okay, so has the widget change state, add that. Global in Python. I don't remember the last time I actually called global in Python. Not always a good idea, but necessary here. And then we update the bar chart, and then the bar chart does what you expect. It filters the data based on the current widget state, updates the title, sorts the axes, sort of a hack to get to sort everything by percent, so it's like nice and clean. So the largest thing is at the top of the bar chart, and the smallest is the bottom. And then what it does is it updates the data. It doesn't actually update it doesn't actually specifically update the chart. What it does is it updates like a global variable called source, which has the data for the chart. So we're just updating the data behind the chart that's going in there. And then at the bottom, we like say, here's the current document, and we add the layout to that. When we want to run these, it's a command line utility. It's like bouquet serve, and then that just works. Okay. So kind of the takeaways from this, these are my takeaways. Like R Shiny is like really popular, and I think rightfully so. It integrates with like everything that our users already know. They know ggplot2, they know like RStudio, they're already using it. It's an older, like it's been around for a while, so there's tons of documentation examples, very quick to get started. Bouquet server, little bit of a learning curve, slightly more verbose. Pretty powerful though. And the bouquet code that you use, like the plotting code, if you learn that, you can use that in Jupyter notebooks as well. So you can kind of like, you don't have to learn one thing just for one purpose. Awesome. So everything so far has been kind of like the dashboard. This is usually what you might share data like. It's like, here's the dashboard, here are the charts, explaining the charts, you can filter the charts. But there's more that you can do with data science web apps. And I think this is actually what's really interesting, because this is kind of like, since this is like new, this is like stuff that we haven't been able to do with data before. And so this is going to like open up, I think, a lot of opportunities in like what we can do. Okay, so here is a, I don't know if this is actually great, but it's really, it's kind of interesting. So what this is showing is volcanic eruptions for the last 200 years. So like this is showing the Pacific, what is it, the Ring of Fire, like Indonesia, Japan, the Aleutian Islands in Alaska. Most volcanoes in the US actually happen in Alaska, which is a fun fact. All of this is actually embedded in the browser, which is really cool. So there's no server running this, and this is all R code. I didn't write any JavaScript. So I don't know if you'd use it, but I think it's cool. This is more useful. So this is a clustering tool that one of my colleagues wrote. So what this is doing here is it's helping someone define how to like pick keywords to cluster things. So right here, I was typing in like sort of baseball terms. There's 20 news groups data backing this. This is saying like, here are these words. What are similar? Like what words did I forget? And then adding them in. And this is like creating a cluster, a text cluster, a topic. Here's supernova. Baseball and supernova, they obviously go together. Galactic, black hole. Seems like it's working pretty well. This one is definitely the cooler topic. Absolutely. So then we can set the topics. This is like the JSON, and then if it'll go to the top here. And then we can show that like using this tool, we can use these topics, and it will actually like classify the document itself and give us a bar chart. So this is all built with IPy widgets, with Jupyter widgets. I think is kind of amazing. I haven't seen anything else this extensive built with Jupyter widgets. It's running in a notebook, so you couldn't like serve this over the internet. You'd have to pass them the actual notebook to run, and that's sort of just like the design of Jupyter notebooks. I wonder if that's going to change with Jupyter Labs. It very well may. So that's real cool. Mike is awesome. And here is like one last app. This is another Shiny app, and this is an app used to to find so that employees at Civis can find mentors. So like if you want to know something about deep learning, you would say like, who at Civis knows about deep learning that I could ask questions to? And what's neat about this is it's accessing data from Google Docs. So at the company, everyone will type in like, this is what I know. It's just voluntary. You put it in Google Docs. That's like the data input. And then this will just pull that data and like have this nice front end. It's built with Shiny and Shiny dashboards. I think that this layout looks really cool. I think it looks like pretty professional. And that was built by another one of my colleagues. Okay, great. So just kind of wrapping up all of these things that you can kind of do with data science web apps, like beyond just showing reports, which is already a big win to be able to like create your reports with programmatic code. But you can do more, like live optimization. So we have one thing that we do for a client where we have like this kind of custom optimization and like a bunch of filters, and the client will like put all these filters in, and then the optimization will run and say, output a chart and say like, this is the choice you should make. And that's been really successful. We have like real-time model scoring, model inspection. They were talking about Line yesterday. It's very cool. So you can imagine you could build an app where somebody has an image and they upload the image to the app, and then it says like, here are the objects in this app. And then it also shows you like with Lime or Shape is another one to do this that I don't know too well though. Like here is why it's making this prediction. So you get like both what it's predicting and why, so you can like actually trust that it's doing something useful. This is sort of, I showed like a clustering app that you could use. I can also think that you can use data science web apps for like matching. This is a problem that we work on as well. So it's sort of unsupervised in the sense that you don't always have like a labeled data set, and you want to like say, how are my matches actually doing? Like, is this matching things reasonable? Like, what is it missing? Like when it is low confidence, like what does that look like? When it's high confidence, what does that look like? And if you build an app like that, it's just a lot faster to do that. Otherwise, you're writing a lot of SQL queries. But SQL is awesome, but it's just not as fast. And then finally, I can think of like human in the loop apps. This would be really cool. So you can imagine an app where you have an image and you have a model, and it classifies the image, and it gives you like the top 20 predictions for that. And then you say like, okay, you have a human like actually look at see which of these is correct, and then you like gain more data, and then the model improves over time. And that's just a much faster way to do this. Well, especially then like some things just have to be annotated, and if you can use like some machine learning as like a starting point, then you aren't, it's not like you're starting from a random point and then you have to take so much more time to get something useful out of it. Okay, so that is a very brief and fast introduction to the data science web app scheme. This is fun, so now we have time for questions.
Can you flip back to that summary?
Certainly.
Thank you.
In the back?
You said there's no standard for Python yet. What would you say is the front runner, or what do you think will become the standard?
I don't know. So this is tough, and this is actually like, again, this is like the biggest reason why we even started looking in this. I don't want to pick one. I kind of think that like if something was related to Jupyter, that's sort of what everybody knows. That's sort of the brand name. In the R community, there's like RStudio is the company. So whatever Hadley Wickham does or whatever RStudio does, that's what everybody uses. And it's a gift and a curse, right? So it's not like you don't really necessarily want like one group to like only have control of the whole language. but then you do kind of like know like this is what everybody else is going to use. This is what I should learn. So I don't know. We missed the Dash talk yesterday. That is a pretty promising approach. So Dash has like a conception of like it uses like React templates, so that should be pretty nice to create. And then it has like a Flask backend. So I'm pretty excited about Dash.
Would you be able to share what one of the files that you shared looks like? 'Cause I've never seen this before. But so say if you have a non-technical user, what would the files, that output file look like for that?
Yeah. Okay, yeah. So let me just flip back for a second. I can show you some things. So like, I mean, if you this is like just what you'd have like a website, and then they would navigate to this website, and what they would see is this. I didn't open a browser because I didn't want anything to go wrong. So this is just why I'm taking screen caps.
So you just provide them like a browser link?
Yeah.
And then, so where would it be hosted?
That's a good question. So there are many ways to do it. This is like one thing that like we're trying to sell is like a good way to host these, not just in terms of like hosting them is one thing, but then there's also like maybe these are running jobs in the background. So like an easy way to like run the jobs in a secure environment. So I think a lot of times you're probably going to have to pay to deploy these, but all the code is open source. Let's go back here. I kind of want to just leave it on this because, no. Any other questions? Sure. I'm happy to share the slides. I think, if I'm not mistaken, PyData like posts the YouTube and then like you send PyData the slides as well. So I think that probably through PyData will be the easiest way to find them. Yeah. Another question.
Usually handle like the production of these web apps.
Sorry, say that again.
How do you maintain production of these web apps? Do you like work with engineers or like mechanics?
Oh, that is. So the question is, how do you maintain these web apps? Which is a brilliant question. So this is the interesting thing. So like, again, with great power comes great responsibility. So if you develop this app, somebody's going to have to maintain it if you like pass it to a client. So this is why like you should usually do as little as you like, make your app as simple as it can so it's not going to break. So like at our company, we kind of share responsibility. I'm on the hook for a bunch of these apps. Sometimes we pass them along we have a dedicated engineering team. And then you have PagerDuty. Any final questions?
Why can't the Bouquet developers repackage their Python code so that it looks like the interface you see in R?
So let me unpack your question. So in terms of can you make the output look like what you can do from Shiny? Yes. And are you asking, can you make the like the syntax, like how you program it, look like how you program Shiny?
Well, develop like another class within Python that looks like the interface that you see in R, so that you don't have all the complexity that you were reviewing.
Sure. So like Dash does have a different interface that might be more similar to our Shiny. I also think that like, I guess you definitely can. You definitely can. I'm not sure it's always like the right approach is just to like do exactly what Shiny is doing. Because like in some ways, like why not just use Shiny if you really want that? And like, it's not necessarily Pythonic. It's a little magic. So I don't necessarily know if like that's the right choice. And the Bouquet developers definitely know more about this than I do. So like I defer to their kind of like expertise on that. Okay. That looks, oh, one more. Yes.
So it seems like you mentioned Hadley and what's going on over at our studio.
Yeah.
It seems like one of the issues there is like Hadley has no problem effectively plopping another DSL on top of
Oh
R,
yeah.
creating like his own vernacular on top and saying, I'm doing this because it like shortens their language, right?
Yeah.
They do that with wild abandon.
Yep.
And in this community, there's a lot of cultural resistance from that. Is what we're seeing the result of that, or is there like other factors that we're missing?
Oh wow, that's like hitting the nail right on the head, I think. So, I don't really want to like offer any preferences, but just to recap what you said. So he's saying like in the R land, Hadley is basically rewriting a DSL for R, and it's called the tidyverse. And in Python, everything is kind of sticking to like trying to be Pythonic is like the API, and not writing things that are easier to use, quote unquote, but aren't like Pythonic. I don't know. I think that like the world needs everything, so you need both. And I think the Python's philosophy of like do the thing that's like has the least surprise does make sense a lot, and maybe there's more surprises. And the R syntax though is really wonderful. If anyone learns R, like our consultants like that are like not, they don't care about programming, like they care about getting stuff out the door. They love it. So I think that there's a lot to be gained from understanding what's going on there. Cool. Thanks, everyone.